at noon, so you're all invited to come to Melinda's talk. On Friday, the Department of History and Philosophy of Science is also hosting a talk at 3:30 on the 10th floor by former Center Fellow Tushar Menon. The talk is The World According to Quantum Mechanics, so 3:30 on the 10th floor on Friday as well. Next week, on Tuesday, we have another lunchtime talk given by one of our guests, Eduardo. Where is Eduardo? Oh, right there. Eduardo Peruzzi, who is visiting us for 2 weeks. So he's a philosopher of economics, doing postdoctoral fellowship at the University of Leibniz University Hanover, I guess the best possible university, I suppose. Eduardo will be talking, such a nice name. It's almost as good as Eduardo. We'll be talking about model transfers through formal constant accumulation. So we're looking for that talk, looking forward to that talk on Tuesday next week. If you plan to come to the conference this weekend, the Philosophy of Neuroscience, that starts on Saturday morning, please register. The deadline for registering is Thursday. Please do that. The program of the conference is on the center's website. Today, it's my pleasure to introduce our speakers, Margaret Farrell, who got her PhD from LTS, Logic and Philosophy of Science at Irvine in 2025 with Kyle Stanford, who actually was maybe the first senior visiting fellow here at the center a long time ago. Margaret works, she's a postdoctoral fellow right now at the center for the whole year. She works in the philosophy of biology. Her dissertation was about epistemological issues in the explanation of the evolution of human cognition. She worked a lot on the nature of narrative explanation in her dissertation. And I will just mention that she just had a paper published in the last issue of Biology and Philosophy. So congratulations. The first of many, I'm actually sure. And today, Margaret will be talking about what would imaginary ancestors do. Floor is yours.
Thank you, Ed, on the board, and thank you all for coming. This is very special for me. I used to come to lunchtime talks as an undergrad. I really didn't imagine I'd ever be giving one. But that's about imagined futures, and really I'm here to talk about imagined past. I called this talk, What Would Imaginary Ancestors Do? This is the same title of the article that I published earlier this summer. It's also a chapter in my dissertation, but there's some more stuff from my dissertation here that's not in that paper. This is a talk about evolutionary history, about human cognitive evolutionary history. So the big question is,
every Tuesday and every Friday, don't you worry.
Where you put the first? Why are we like this? We do things differently than our nearest extant relative species. Humans seem to have unique features of psychology and behavior, unique linguistic capacities, moral psychology, cooperative behaviors, social organization, technology, production, and use, not to mention the broader traits of morphology, geographical range, and life history that are different from our evolutionary relatives. Why? Of course, there's lots of ways to interpret a question for why are we like this. So we'll sharpen it a bit for this context. Why did humans end up with the features that we have, while other related lineages did not? This is a question about evolutionary history. The evolutionary history of species typical and species unique traits is the explanation for why we're like this and not like that. And all of this, at least in principle, without something like anthropocentrism. Every species has species typical and species unique traits. Maybe ours is especially interesting because of us. But in principle, these kinds of questions you could ask about any species. And people do, that's evolutionary biology. Okay, why would you do a science like this, or why would you be interested in looking for an evolutionary history? It's notoriously really difficult to reconstruct the evolutionary history of human cognition and behavior in particular. But the fact remains that it did evolve. Other things that we know about evolution and about nature tell us really confidently evolutionary history has to have something to do with the way that we think and behave. We know that cognition and behavior in general across all species as a product of evolution or has something to do with their evolution. So whatever the right answers are, whatever human cognition is really like, evolution has some role to play, whether it's big or small, in the true story of why it's like that. So we'd really like to know what that role is. That's like a truth reason. As far as implications or consequences, you might think that the answers about evolutionary history matter to some of the big questions that at least philosophers, naturalist philosophers care about. Anything that overlaps with naturalized philosophy about human nature, Edward's notion of human nature is evolutionarily based. Anything having to do with the traits that a species has in virtue of its evolutionary history. I have a cursor back. Other really persistent philosophical questions. This is good. This is okay. Other really persistent philosophical questions about free will, attributing intentions to others, or about ethics. Some people really care about how our moral psychology interacts with our ethical principles and beliefs. You might think that knowing what the true role of evolutionary history is would help you or would have some bearing on that question. And then, of course, in a lot of societies, people really care a lot what science has to say about human behavior and about why people behave or think in the way that they do. It impacts a bunch of social norms and not just out of curiosity. Sciences of mind and behavior have historically been and continue to be marshaled to back up things like scientific racism, sexism, eugenics, using the social authority of scientific knowledge. So it's really important that scientists are producing and sharing good, well-supported, carefully constrained hypotheses, even though, of course, bad actors and special interests can always abuse science no matter how good it is, but at least it should be good. So that, because the stakes are kind of high, this impacts how people think about each other and how people treat each other. Persistent question, though, for evolutionary theorists is how to reconstruct that history in light of the associated challenges, most notably that evidence for past cognition behavior is relatively scarce and difficult to interpret. So my goals for the talk are, first of all, just to tell you about my dissertation and how I'm going to work. That's the easy one. I also want to convince you of two things. The first one is that there are principled strategies for making the most of limited evidence for cognitive evolutionary history. And more specifically, I want to convince you that I've identified one. And then I will want to complicate it because, of course, that doesn't make it easy. I'll show there's a special complication for the strategies having to do with our evolved human brains. So the plan, the agenda for the rest of the talk, I'm going to introduce hypotheses for human cognitive evolution that I'm interested in here. I'm interested in a cluster of relatively recent ones that aim for the really broad in scope, and they aim for, if not a comprehensive, at least a really synthetic picture of human cognitive evolution. So I'll have to introduce those and situate them a little bit. And then I'll show you some strategies for handling the familiar problem of limited evidence in the evolutionary history of our lineage. This will involve talking about some strategies that other philosophers have identified and then introducing my own. And then I'll get to the really title issue, what would imaginary ancestors do? This is going to be a challenge to inferring associations among cognitive capacities in past ancestors. And then I'll finish just by summarizing and telling you about some of the questions I want to work on next. Okay, first, hypotheses for human cognitive evolution. Throughout the 20th, 21st centuries, there have been several or many really approaches to figuring out evolutionary history, as well as how modern evolutionary theory can help us learn about human behavior. The really big ones coming from the psychology ecology side of things have been human sociobiology and evolutionary psychology. It should sound familiar. Human sociobiology, introduced by E.O. Wilson, was an application to humans of the more general science or general field of animal sociobiology. It was famously kind of pretty speculative and pretty thoroughly criticized both inside and out of academic circles for conflating adaptive value of human behaviors in the past and present environments, neglecting the complex interaction of environmental factors or other factors other than selection on gene variants and producing behaviors. In the 90s, it was sort of replaced, but also sort of morphed into a field called evolutionary psychology. And I'm following a convention here. Capitalized E and P is for the kind of classic evolutionary psychology. You can think of Tooby, Cosmides, Jerome Barkow, Steven Pinker. This is a convention from David Volker about referring to that paradigm or that kind of evolutionary psychology. This is also thoroughly criticized for a lot of the same reasons, the way that they applied or continue to apply evolutionary theory, some foundational assumptions like defaulting to a mostly or entirely modular organization of cognition, and the ways that they collect and interpret evidence. But really, there's a bunch of different ways of trying to understand human cognitive evolution. There's the whole tradition of paleoanthropology, and what some philosophers are calling an emerging field of cognitive paleoanthropology that combines archaeology, paleoanthropology, and cognitive science. Other parts of evolutionary biology, human behavioral ecology, lowercase evolutionary psychology. You can call this lots of different things. There's lots of different ways. I'm interested in this cluster of recent hypotheses. Are typically in these like long books. Some of these are long, and they're usually authored by one or maybe two people. These are some of the examples that I focus on in the dissertation. Typical classifications, like on the previous slide, would place these among a bunch of different approaches. Celia Hayes' cognitive gadgets is usually with cultural evolution. Sarah Hrdy's Mothers and Others is in anthropology, primatology, or sociobiology. That's what she calls it. Strelny and Planer, their work in Signal to Symbol usually gets put with gene culture co-evolution, sometimes cultural evolution. And Tomasello's work, that we're going to talk about a lot, is typically categorized in social and developmental psychology, comparative psychology, or lowercase evolutionary psychology. These classifications reflect the content and the expertise of the authors, more so than the structure of the resulting hypothesis. In my dissertation, I try to call them narratives, and I try to say there's a reason to call them that. But I'm not really concerned about narratives in this talk, so it's not very important that you accept that that's why they should be grouped together. It's enough for you to know that they are recent. The authors take themselves to be doing something different than classical, capitalized evolutionary psychology, and that they're relatively well received, even if some of the older ones have turned out to be less comprehensive or kind of gotten folded into more recent ones. So each of them aims to build a detailed history to some extent. They aim to uncover when and how our uniquely human cognitive capacities evolved. For example, capacities for mind reading or theory of mind, moral psychology, hypercooperation, etc. And what they do is start with the best characterizations that we can get of modern human cognition, other extant species cognition, and inferred cognition of the last common ancestor. Then they want to know what the important events were that made a difference to the selective pressures affecting ancestral hominins, and how this impacted their behavior, survival, and reproduction, such that modern humans ended up with the cognitive capacities that we have, while other lineages ended up with the capacities that they have. Sarah Hrdy puts this question, the central explanatory question, as why us and not them? Why are humans like this and other lineages are not? So I'm going to show you some of the strategies that historical scientists, evolutionary theorists, authors of narrative hypotheses like those can use when they're trying to put together these broad scope synthetic hypotheses. Okay, but first, here's a little bit more about the idea of there being limited evidence in this field. when the theorists are writing a hypothesis like the ones that I showed, they generally want as much detail as they can get. It's not true across all the sciences. You know, there's lots of different reasons you might want different amounts of causal detail, but they want more causal steps. And this is tricky in the historical sciences, especially in human cognitive evolution. Material traces such as fossils or preserved artifacts. Here are some fossils, photographs of fossils, and some material artifacts from the material record. These are often considered the prototypical source of evidence for historical scientists. But as philosophers have often pointed out, the material record in general is a sparse representation of the traits and variation of past organisms, and the fossil record in particular for the hominid lineage is very sparse. Although, of course, there's a lot more than this. This makes it look much more sparse, but there's a lot more than that. And for cognition and behavior especially is difficult, because what we have is either the physical housing for cognition and behavior, or its products like artifacts and tools. One way of responding to this problem of sparse evidence, is to adopt a really conservative methodology, relying only on very direct inferences from material traces and just accepting that the resulting hypotheses are going to be less informative or way less certain than hypotheses in other disciplines. More optimistic historical scientists and philosophers respond to this challenge by developing and analyzing other ways that historical sciences can use the same evidence or in conjunction with other evidence to make less direct inferences that go beyond something like very direct observation or measurement, and can still be tested or asserted with proportional confidence. So this is kind of an analogy. How to Cook a Wolf is this cookbook, memoir, and survival guide by MFK Fisher. It's also the namesake of a restaurant in Seattle. The title plays on this metaphorical wolf in Charlotte Perkins Gilman's poem, The Wolf at the Door. The wolf at the door is a representation of, among other things, urgent hunger and the threat of starvation. When the wolf is at your door, you're starving. Fisher's cookbook instructs readers in using the creative use of minimal, basic ingredients, written in the context of scarcity brought on by the Great Depression. When the wolf is at your door, you cook the wolf. I like this analogy because it really emphasizes making the most of what is accessible, rather than, for example, talking about generating new evidence. This is kind of a discussion in philosophy of historical sciences. So not generating new evidence where there wasn't any before, but really making the most of what you can access. But we should note that a major motivating factor in the idea of adopting a really conservative methodology was about unchecked speculation. These more optimistic analyses of evidence in historical sciences, you run the risk of inviting or invoking speculation. And of course, ideally, we're not going to invoke any blatantly unsupported speculation. No one's saying we should make claims that can't be supported, but we're trying to kind of thread the needle, balance the responsible use of evidence with methodological innovation. So here are some ways that human evolutionary theorists cook a wolf. One of them is a minimum capacity inference. This involves inferring the past cognitive capacities of some agent from the artifacts that they produced by determining what cognitive capacities are required to produce them. Another one that I'm calling available and useful capacities. This is from Strelny and Planer. They just don't have a proper name for it, but that's how we're going to refer to it, where they infer past cognitive capacities from their inferred availability plus adaptive value. And then what I've been calling functional and historical associations, where theorists infer the presence of a past cognitive capacity by associating it with another one, or inferring its relationship to a close ancestral capacity. I'm going to show an example of the first two, because it kind of gives an idea of what I mean by an inferential strategy, or a pattern of inference, or a way of using material evidence in maybe a not obvious way. So the first one is a minimum capacity inference. This has been identified by philosophers of historical science and archaeology. They identify what archaeologists make this kind of inference that they call a minimum capacity inference. When they're making an MCI, an archaeologist first asks what are the minimum necessary competences for an agent, any agent, to produce an artifact like a stone tool. Then, on the basis that these abilities are strictly required to produce it, the archaeologist infers that the maker had that capacity. This is an example from Ross Payne that he identifies in one of the papers where he introduces this kind of inference. The central claim is that the production of prepared core technologies, such as the Levallois, requires long-term working memory. The archaeological record indicates Neanderthals were using the Levallois for thousands of years. Consequently, Wynne and Coolidge, archaeologists, conclude that Neanderthals possess long-term working memory capacities. The key insight is that the evidence, the material evidence, is not only evidence that it was being produced at the time that it is dated to, but also that the maker had the capacities required to produce it. The second example is from Sterelnian planers hypothesis in from signal to symbol. There's no special or proper name for this, but they do make it explicit. They say our standard pattern of inference is to use the material record to identify the availability of cognitive and social resources for particular communicative capacities, and to use that same record to identify communicative needs that select for those capacities. If capacities were both available and useful, then they probably had them. The population in question probably had them. This strategy has two parts. They want to infer that an ancestral hominin population has some particular capacity. So for one part, they do some adaptationist type reasoning. They say, what would it have been useful for in that environment that they were in? And then they do some historical, comparative, et cetera, type argument to say that that capacity would have been available, and that if pressured, if selection pressures existed, they could employ that capacity. They use this strategy to support the idea that erectines like Homo erectus and similar had a kind of proto-language. This is an example I talk about more in other places, but we won't get into today because to spend the time on other examples. Okay, so those two should give an idea of the kind of thing that I mean by an inferential strategy or strategy for adding detail with limited evidence, making connections that do connect back to the material record and experimental evidence, albeit indirectly. But something that theorists often try to do, something else they often try to do, is connect cognitive capacities to other cognitive capacities in some way. You can contrast that with a minimum capacity inference, which connected a capacity to a material artifact. There are two related strategies that I identify, and bear with me. There are examples coming, but they take a bit of background to get into the example. So I think it helps to get this kind of somewhat abstract description out first before we get to the examples. The first one I've been calling a functional association, involves inferring that a population has had some capacity for which we don't have material or trace evidence by showing that it is functionally associated with another capacity for which we do have such evidence. And the other is an historical association involving inferring that some capacity or ability could be gradually enhanced so as to produce significant change in ability without significant change in underlying cognitive features. I think that each of these really involves a claim that certain capacities are close enough to one another in some sense. Here's another way of stating those strategies. Some capacity X is close enough functionally to capacity Y, such that if a population had X, they also have Y. In a historical association, some capacity X is close enough to a slightly improved version X star, which is close enough to another slightly improved version, and so on, eventually close enough to the novel capacity with no significant change in underlying cognitive architecture. And of course, this has to be spelled out in the relevant evolutionary sense. I'm calling these close enough judgments. And in principle, there's nothing wrong with this. So I haven't made any kind of critique yet to the idea of making this kind of judgment. And especially when I'm under what I'm calling historical association, it should sound kind of normal. I mean, we always expect evolutionary theorists to adhere to standards of good reasoning about adaptation. Adaptive hypotheses should be based on our best knowledge of the phylogenetic relationships among extant and extinct species. We may not assume that a trait's current function is identical to the function for which it was selected originally as in its emergence, and it must be developmentally, biomechanically, or ecologically plausible that a novel trait could have emerged as a modification of an ancestral one. Close enough judgment might just sound like a name for that last thing, that evolutionary changes that you propose have to be developmentally, biomechanically, or ecologically plausible. So I want to motivate why I'm picking it out as a piece of evolutionary reasoning that needs examination. Here's an account of one kind of evolutionary explanation that addresses a requirement about plausibility. This is Brett Calcott's notion of a lineage explanation, which I will note that Sterelny and Planer do reference as a kind of ideal for what they want to produce in from signal to symbol. Lineage explanations trace how a mechanism could change over time to show continuity between one form and another. In Calcott's major example, this is the evolutionary developmental explanation of the mammalian eye. It's the focused lens eye. And he writes, the same 3 layers of cells are present throughout the stages. Their shape, size, and relation to one another are modified, but the credibility of continuity between the stages is justified because there's no radical change in parts or their properties during the transition. In this account of a lineage explanation, Calcott argues that the specific nature of the transition from one stage to the next is not really very important. What's important is that there be no radical change. But I disagree. The judgment that one stage is close enough to the next is crucial to an explanation overall, or an evolutionary explanation overall. In this case, this is an evolutionary developmental explanation, the sense of no radical change is probably actually based on a theorist's trained sense of plausibility relating to biomechanical complexity, evolvability, the number or kind of mutation that could produce the positive change, which is all effectively an informal appeal to really legitimate background theory. In this case, it may be harmless, but it's sort of fortunate. It's only because intuitions about no radical change happen to probably be good proxies for justified background theory. What we should take from this is that judgments about close enough in the context of evolutionary explanations, close enough steps, they're always based on something, even if it seems obvious enough that we don't have to specify it, because we won't be so lucky in human cognitive evolution. So both of the strategies that I've identified really involve 2 claims that need evidence. In a functional association, it's evidence for the presence of a capacity plus a close enough judgment. In historical associations, it's evidence for selective pressures and coevolutionary feedback loops, perhaps, plus a close enough judgment. And each of those needs particular kinds of evidence that ties them together. So for functional associations, we need evidence that ties the functions together cognitively in a way that doesn't only observe that they're somehow associated or related or concurrent in modern humans. The association is only relevant if it's present at the relevant point in the evolutionary path. For historical associations, we need information about evolvability. And in fact, on the point, evolvability is, I think, the sort of prototypical kind of evidence that you would need in historical association. As I've described it, evolvability is a dispositional property of a population. This is from Rachel Brown. It's a measure of their capacity to change over time with respect to some future state, given some starting state of affairs. It is therefore in part a measure of how easy it is for a population to move over time in particular directions through design space. And we need to remember that. This is about how easy it is to move through design space. But it seems like, so far, it seems like something like a close enough judgment will require different specific evidence in different cases, case by case. So what do we get out of grouping them together based on this close enough character that they seem to have? it's of course, I kind of said this, but it's of course a basic expectation for scientific reasoning that theorists avoid bad practices like wishful thinking or wild speculation. But it's useful. So we assume in good faith that they're not going to do that. But it's still useful to find the breakpoints or weak points of the methodology that we're looking at, especially when we're trying to make the most of limited evidence, to find points where you might need extra regulation or extra care in the kind of the way that you're thinking about it. And close enough judgments are one of these points. And this is how we get to imaginary ancestors. So in this part, we'll see examples of both kinds of association, but we'll also see the challenge that I think theorists face when they try to make those associations. I have two examples, and they both will take a bit of background to get oriented. The first one is the shared intentionality hypothesis from Michael Tomasello. This is from his book, A Natural History of Human Thinking. The hypothesis posits two major shifts in evolutionary history of human cognition, and together they make this narrative. The beginning of the story is individual intentionality, the type of thinking in which an organism can represent experiences, simulate the effects of actions it might take related to those experiences, and take such simulations into account in determining its own behavior. So great apes can do this. The thinker represents the behavior of another, but only as a relevant feature of the environment. They may exploit cues from a competitor's behavior as a relevant factor in their own behavior, but it does not conceive of other agents as having intentions like its own. The first shift is the emergence of joint intentionality. This is a kind of thinking in which at most two partners can conceive of themselves as jointly holding the same intention while also representing their own respective individual roles and perspectives. The second shift is the emergence of collective intentionality. These are original proposals from Tomasello. So joint intentionality is his term, and collective intentionality is also his, which is the abstract group-oriented thinking of modern humans. Modern humans can coordinate with any member of the group as opposed to the transient pairs of joint intentionality. Modern humans have objective representations, intersubjective representations from anyone's point of view, and they make inferences based on reasons that anyone should find compelling. They adhere to norms that apply to anyone, etc. This is a coarse-grained flowchart, of course, and there's many more steps and lots of discussions of different kinds of evidence throughout the actual hypothesis. What I'll be concerned with for the example is one of those finer grain steps. And this is the emergence of abstract linguistic constructions. So this is part of the second step, the second shift in going from joint intentionality to collective intentionality. And as an example, abstract linguistic constructions are these generalized forms: X verbed Y, Margaret saw Martha, Joe ate popcorn, or X verbed, Margaret smiled, cried, swam, or talked. And Tomasello thinks these are really important and that they actually enable some forms of thinking that are constitutive of intentionality. So he's very interested to show how abstract linguistic constructions emerge. The sequence that he has in mind to connect jointly intentional early humans to collectively intentional modern humans is something like this. Jointly intentional early humans have conventions, arbitrary signs for single unit communications. Tomasello's favorite example is sticking your hand out to sign that there's a snake, to sign snake danger, he calls it, that there's a snake nearby. Sticking your hand out is a conventionalized form of the iconic wavy hand, which everyone knows is a snake. So, which is itself, that's a whole other thing. This is something that he thinks jointly intentional hominids have, are arbitrary single unit gestural signs. Then they generalize those single unit conventions into multi-unit conventions and generalized item-based schemas. And then these get elaborated under pressure from ambiguity in discourse until we get things like fully abstract linguistic constructions where different constructions encode different meanings. Constructions like It was Margaret who wrote the window and chose a different meaning than Margaret wrote the window. And the first one, you might say that because the listener thinks it was someone else. I'm correcting them, no, it was Margaret. But the meaning encoded in the second one might just be informing one another that I've done something terrible. The particular step that we're looking at is this first one, where jointly intentional agents, early humans, begin to use generalized item-based schemas. So Tomasello is going to try to show us how did that happen. We're going to do a thought experiment. So feel free to close your eyes. Do whatever you need to do to really engage your imagination here. It's kind of a long block quote, and I'm going to read it out loud. If we imagine early modern humans with a small inventory of single unit holophrastic communicative conventions, along with general cognitive abilities for creating novel mental combinations possessed by all apes, we can easily imagine them creating multi-unit linguistic combinations. And so, for example, perhaps there was a communicative convention for requesting eating by moving the hand to the open mouth. Perhaps there was an unrelated communicative convention for requesting going foraging for berries. I'm a picking emotion. It would not take a genius in a situation in which someone offered something unpalatable to eat to gesture eating followed by berries. Then, given an existing ability for schematization possessed by apes and early humans, but now applied to conventions, one could imagine this individual generalizing the conventional eating gesture to other conventional food gestures, much like human toddlers do, as they first say things like more juice, followed soon by more milk, more berries, and so forth in more X pattern. So we need to be convinced first here that when a communicator with a certain set of capacities is faced with a situation in which it would help to make intentions explicit, it would recognize this fact and forge novel connections among conventions with ease. And second, that once such a novel connection is formed, it is similarly easy enough to generalize and apply this pattern to other conventional gestures. The inferences described in the thought experiment, first the creation of the new conventional phrase, eat berries, and second, the generalization of that combination's form to other conventional gestures, must be plausible enough to conclude that inferences of this type were easy enough for early humans who have only holophrastic communicative conventions and a general ability to create novel mental combinations and schematizations in other domains. We're supposed to find it plausible that an early human could string together conventional representations of concepts eat and go foraging for berries in response to being offered something that they don't want to eat. And they mean, I don't want to eat that, I want to eat berries instead, let's go forage for some berries to eat. And then we have to find it plausible the same individual could generalize that innovation and apply it to other conventional gestures. But to convince us, Tomasello asked us to imagine an early hominin with just those first two capacities, and says that we can easily imagine them beginning to use multi-unit conventions in novel mental combinations. It wouldn't take a genius to do so. How easy is it to create multi-unit linguistic conventions given only holophrastic conventions and the capacity for novel mental combinations in other domains? And how easy is it to apply the ability to schematize in other domains to these new multi-unit conventions? When we answer that question, when you say how easy it is, how easy that seems, we're assessing how easy it would have been for an early human to make the kind of connections that we routinely make using our capacities for abstract linguistic construction. As a modern human, with the ability to innovate with multi-unit conventions, it is obvious to me that appending the gesture for eat to forage for berries should modify the meaning just so. And it's obvious that I could do this across a variety of communicative contexts. It'd be really useful to do that. But we're not really in a position to evaluate how accessible such inferences would be given only those ancestral capacities and without employing the capacities that I already have. So I can't think about how easy it would be to do this without employing the capacities that I have that do this. This is the problem with treating that intuitive ease as the reason to think that this went this way. This is a functional association thing. Early humans that had these capacities probably also had those. And remember, here's where the close enough judgment is. Remember that we needed additional evidence for the close enough judgment to say that making generalized item-based schemas and multi-unit linguistic combinations is close enough to these capacities that we hypothesized the early humans having. Remember that we needed evidence for that, though, for the close enough judgment. This was an empirical claim. What's doing that work in this case? It's the alleged ease. It's this intuitive sense of ease that was appealed to when we were asked to imagine it or to think about how easy it would be to imagine or how it wouldn't take a genius to do it. It's this alleged ease with which the imaginary hominin would be able to make the inferences described that renders plausible the claim that abstract linguistic constructions would be achievable for hominins with only these capacities. In the thought experiment, Tomasello isn't just overlooking the need for empirical evidence beyond that which supports ascribing to early humans these capacities. He explicitly relies on the thought experiment. This is explicit relying on intuition. We surely can imagine a hominin with these capacities Tomasello described, but we can't intuit what else they would be able to do. We don't have access to a cognitive experience without our own evolved capacities, and our intuition is a poor judge of how much of a stretch some previously unmade inference would be to our ancestors. So our intuition doesn't really tell us that these are close enough. It's not reliable. Now you could, so you can't make these judgments about close enough judgments or plausibility on the basis for, the basis can't be your intuitive sense of plausibility, but it is in principle possible that the intuition could be replaced by some more appropriate empirical evidence. In that case, it's crucial that the intuition be replaced because it's sourced from this unreliable intuition. It can't serve as evidence even in conjunction with other appropriate evidence. This is a second example, and this will be an example of historical association. So this first one was functional association. This is another hypothesis for the evolution of uniquely human cognition from Kim Sterelny. He presents an account centered around the operation of two feedback loops. One is between expertise, social learning, and life history, while the other is between expertise, individual adaptations for social learning, and organized learning environments. It's that second feedback loop that we're looking at represented here. These feedback loops describe the causal relationships that allowed the hominid lineage to accumulate social knowledge and respond adaptively to that accumulation, eventually transitioning to cultural knowledge and modern forms of human cognition. Put briefly, Sterelny's hypothesis is that as hominins, Sterling's hypothesis briefly is that as hominins develop technical competences like toolmaking or food or resource manipulation, they inadvertently enrich their environments so as to gradually increase the structured learning of other hominins, including their offspring, especially their offspring. This initially accidental enrichment contributes to accumulation of competences across generations, providing selective pressures favoring longer childhood. That's the life history part. What's really important in Sterelny's account is that this process is what he calls apprentice learning. This is a kind of social learning with the general format where an apprentice learns from an expert by observing the expert's actions, taking on small, relevant, informative tasks delegated by the expert, and learning from the structured environment that the expert maintains. He thinks this can be constructed incrementally in evolution in just the way that would make it attainable for something like a feedback loop. He also especially emphasizes that it can begin accidentally, or it can begin without very much input. This is a historical association, or it's really a feedback loop in general. Like this is a kind of historical association, which says that small changes in each of these capacities make small changes in a selective environment leading to small changes in other capacities, and so on. But there's another question that's part of the sequence, it's part of the historical association, about how it gets started. What kind of change triggered hominin offspring to start paying attention to the technical activities of their parents, to find those activities salient enough to hang around and try to figure them out? And what triggered the required initial increase in parental tolerance that he hypothesizes of this offspring involvement? We have to have these initial motivational changes that make it appropriate or easy for hominin offspring to spend time around their parents doing their tool-making activities. But in order to understand how this feedback loop gets off the ground, we have to, ideally, we want to know what made that change, what made ancestral hominins have these changes in motivation or tolerance. And so we kind of have to take this on assumption. He says that the process, the feedback loop, might begin with simple motivational changes. Parents might become more tolerant of juveniles in close proximity and tolerant of them experimenting with adult possessions, tools not in use, fragments of newly extracted resources. Juveniles might become more focused on adult activity. And we have to, for the incremental construction of apprentice learning, it's important that these things happen. These changes have to happen to get the feedback loop off the ground. And Strelny has us take them on assumption, writes on the assumption that young hominins spent a good deal of time with their elders, and on the assumption that those elders were tolerant of children's presence, curiosity, and experimentation, the basic hybrid learning model applies. Given this tolerance and curiosity, it's then only a matter of time before the hominid lineage begins this feedback loop of increasingly sophisticated social learning. This is a historical association. The plausibility that such a feedback loop would emerge in such an environment rests on that assumption that the motivations for parental tolerance and offspring curiosity and experimentation would readily emerge. Strelny is relying on this intuition, this assumption, to motivate the idea that the relevant changes in the salience of adult behaviors and the parental tolerance for involvement of children are simple motivational changes. That is, that it would be easy or simple enough that we can take it on assumption that these two things emerge together in ancestral hominin populations. Intuition motivates the idea that such a feedback loop could get started easily enough. Then Strelny can invoke evidence for the operation of the feedback loops, without necessarily needing to provide evidence of just how they began. The example is pretty different from the Tomasello example that we saw earlier. I take this not to be like a mistake or an oversight of Strelny's. This is a considered decision on Strelny's part, but it constitutes a kind of shift in the explanatory target that effectively concedes one part of the overarching question, why us and not them. If Strelny's right about the operation of these feedback loops, we know that at some point they got started, but we still wouldn't truly know how. In fact, it's possible we might never know how, depending on whether or not specific evidence to replace the intuition comes to light. This is significant. The way that these unusual processes got off the ground seems to be, initially at least, a substantial part of the explanatory target. And although Strelny's work is distinctive in a good way in his appeal to feedback loops rather than the emergence of particular big innovative capacities, it remains that the feedback loops themselves have a causal history. They have a starting point, a set of conditions we would want evidence for as those which produce that starting point. Such evidence is probably really diffuse and exceptionally difficult to identify. You might think it's kind of unreasonable to expect a theorist to provide any more than what seems like a plausible story for how the feedback loop started, especially if you've got a really good argument for the relationships in it once it gets going. That might be totally reasonable to do. Maybe we shouldn't, I'm not necessarily saying Mr. Raleigh should have provided a specific story or specific evidence for how this got started, but it's important to recognize this would be an evidential standard based on the expected availability of evidence, not on some kind of considered theoretical view. There's a reason, though, that we should expect to keep running into this kind of problem, to keep running into places where we want to make a close enough judgment on the basis of intuition. And the reason is that, as Sterling argues throughout his work, coevolution and phenotypic plasticity, genetic accommodation or assimilation, these are pretty much certainly an important part of human cognitive evolution. It's almost certainly the case that some changes in cognitive evolution proceeded by pushing to the phenotypic limits of existing capacities and having those extensions become entrenched genetically or otherwise. This avenue for gradual change is really important in hypotheses that appeal to feedback loops. Existing plasticity in the behavior and cognition of the last common ancestor and descendant hominins was probably crucial. But this is exactly the kind of place that we're going to run into trouble. As we saw in the earlier examples, the limits on the range of ancestral hominid cognition in novel environments are exactly the kind of thing we would like to know and would like to invoke in a hypothesis about the causal steps between stages or associations among cognitive capacities. So here's the trouble, the problem. Just how far ancestral hominin capacities could stretch in changing environments is almost certainly important, but it's just the kind of thing we're in a bad position to reason about. The kind of thing for which evidence will be scarce, and it's a place where we have to make a close enough judgment. It's a place where our intuitions want to come in, but will be systematically unreliable. So just to wrap up a bit, to summarize, I've argued that functional and historical associations are two inferential strategies that theorists use to reconstruct human cognitive evolution. They involve a judgment that one cognitive capacity is close enough to another in the relevant sense, and that one challenge for these judgments is that some capacities appear intuitively associated or intuitively close to others. There's sort of follow-up or next things for this. There are other strategies associated besides these two inferential ones. Theorists often talk about what kinds of events allowed or enabled certain paths or enabled natural selection to act on certain existing traits or open some path. This could be a kind of distinctive reasoning by constraint removal. I open by talking about different approaches to human cognitive evolution. And I think that there's some important comparisons to be done among these different approaches, but I haven't really done that kind of deep comparative work especially with evolutionary psychology, so that's another one there. And I also alluded to this, but there's something funky about the way that these are produced compared to other kinds of science, which is that they're usually written by like one person, maybe two, and the amount and the scope of evidence that they put together is enormous. So much that there's really no one except that person or two people who have that particular set of evidence on hand to think about or evaluate. And I think this might have some interesting implications for the way that that even peers within this kind of approach evaluate the different hypotheses. So that's some kind of forward-looking stuff. So there you go.
All right, we'll take a few break and then we'll have half an hour for